Okay, let's talk about calculating crude and age-adjusted mortality rates using the direct method. So here we have two different populations, population X and population Y. So population X belongs to community X, population Y belongs to community Y. We have this nice table here, this nice matrix that shows you the information that's required. We have 6,000 young and 7,000 older individuals in community X, 8,000 younger and 5,000 older individuals in community Y. So in both communities we have 13,000 individuals. We also have the number of deaths from this horrible disease D, in community X and community Y. So we see in community X there were 69 younger people died during whatever period is that we were measuring, and 115 older individuals died. And then in community Y we had 100 younger individuals die and 60 older individuals dying. So what we need to do is calculate the crude death rate. So to calculate the crude death rate, first thing we need to know is how many individuals died in total. So we're not doing any age adjustment at first. So we can just go ahead and make those calculations really quickly. Here's pull out my calculator. So we have in community X we have 115 plus 69 deaths equals a total of 184 deaths. So we have 184 deaths here, right? We have 184 deaths. 184 deaths. And then we have a total population of 13,000. Population equals 13,000, right? And then in community Y we have 160 deaths, 160 deaths, and a population of also 13,000. 13,000. All right, so if we're going to go ahead and calculate the crude mortality rates, and let's do this. Let's set our rate base at 10,000, given that we're dealing in the tens of thousands, we're not in the hundreds of thousands here. So we only have 13,000 in each group. So let's go ahead and calculate our crude mortality rate. Let me pull out my bamboo tablet here so we can do some work. So yes, so our crude mortality rate so this is for community X, right? Community X. X equals, so we're going to remember we have two strata here. Remember how I said let J equal a stratum equals a stratum, so little j equals stratum. And there are two strata here. Believe it or not, that's an M. There are two strata here, so we're going to summate across the strata, but we're going to summate the number of individuals in each stratum. So that's summation of X sub J, right? Because there's two different strata here, so J can equal 1 to a capital J. And so here we'll say a capital J equals, in this case it equals 2 because there's only two strata here, right? There's two strata here. So we're going to summate all of those X's to get the total number of deaths. So when we summate across the two, we got 184, because in stratum 1 we had 69 deaths, and in stratum 2 we had 115, and when we summate across those we had 184 deaths in total, right? And we know our N, right? Our N is also has to be summated across the strata. So we have to summate the N for each group. So there's N, just a small one, N sub J, right? So we're also doing J equals 1 to J. So we have to summate across the strata as well here, and that gave us 13,000, right? Because in stratum 1 we had 6,000, and in stratum 2 we had 7,000. So we get this value here. So now we're just simply dividing 184 by 13,000. And we get this value here, 0.014. Now, the next step is, we said we want to report this per 100,000 population. So we're just going to multiply this value by 100,000. 10,000. We said 10,000, so 10,000. 1, 2, 3, 4, 5 zeros, right? And it's 141.53. So let's say, let's round it to 141 here. Oops, let's round it to 141 individuals. So equals. So we'll say this equals 141 per 10,000 population. Okay, per 10,000 population. Let's fill that out. So we have the crude rate equals 141 deaths per 10,000 population. So now we'll do the same for the, so we don't have to go through all that mumbo jumbo now, because now we know what we need to do, right? We had 160 deaths in the 13,000, right, for community Y. So now we're just going to divide 160 by 13,000 and multiply that by 10,000, and we get 123. So we get 123 basically. So you know that this equals, so we'll say crude rate equals 123 deaths per 10,000 population. Alright, so there we go. So we see that the death rate is higher in this population, population X, than it is in population Y. So let's go ahead and do the age adjusted mortality rate now. Okay, so the age adjustment, what we have to do is we have to figure out what the death rate is in each group. So let's go ahead and do that here. So what I'm going to do, I'm just going to make this a little alright, let's figure out what the death rate is in each stratum. I should have given myself an extra, you know what, I'm going to do that. I should have given myself an extra column, so I'll just delete this row here. I'm going to delete this row, insert a row here, insert a row to the right, and I'm going to insert a row to the right here, insert a row to the right. Okay. Alright, and we know, so this is going to be death rate. Death rate. Death rate. Just to make things easier, I'll add back another column. Insert above. There we go. So this is community X. This CX. CX. Who is X? Why should I see X? Well, because I said so. CY. Alright, CY. So this is community X and community Y. Alright, let's go. So we need the death rate for each of these groups, right? Why don't we just add another one, just to make it even more fun, right? Row below here, so we'll do total, right? And then we had 13,000, 13,000, and we have here, we did this already, so we have 141, right? And then, oh, sorry, 184, 184. And then we have here 160. All right, now let's go do these death rates. We had this one here. We have this, but we're gonna add these in later. But let's just go do them by stratum right now. Okay, so we have 69 deaths out of 6,000 individuals in community X in the young period, right? So we know how to calculate this value, right? So it's just 69 divided by 6,000. That's how many deaths you had in that population of young individuals, right? In community X. So it's 69 divided by 6,000. That gives us 0.0115. 0.0115. I think I'm going to add another, because we need to know the deaths, right? We need to know not just the death rate, but we need to... Now, let's do this for now. We'll do this for now. So just calculate those death rates. The reason of what I was thinking was maybe I should have another column for our new death rate, so the actual number of deaths, but we're going to do that after we standardize the population, so we'll save that for later. So in the old group we had 115 divided by 7,000, so 115 divided by 7,000 equals 0.016, put 0.016, 0.016. We really don't need that total, but if you want it, that's just going to be what we had before here, so again it's 184 divided by 13,000, and that's just this 0.014, which is what we have down there, 0.014. Alright, and then we can do this, oops, 0.014, 0.014. I guess we can put that total death rate, the crude death rate down here too for the total sample, 0.123, what? 0.0123, okay. So 1, 2, 3, 4, 5, 0.0123.
That wasn't funny, man.
10,000, so it's 50.0123. Okay, so that gives us that. Now let's go ahead and calculate these death rates for the younger group in community Y. For the younger group in community Y is 100 divided by 8,000. This is 0.0125. 0.0125. And then for the older individuals in community Y, 60 divided by 5,000, so 60 divided by 5, 0.012. 0.012. All right. So we're going to be able to answer both of these questions together. Now the next step is to find our standard population. So our standard population is going to be one population to which we apply these community-specific death rates. Okay, because these death rates are only applicable to community X, and these death rates are only applicable to community Y. So we need a standard population. We need to apply those death rates to that standard population. When we apply the death rates to these populations, they don't translate well. So we have to standardize the population. In other words, we have to apply the same population to both groups. So we're going to assume that both groups have the exact same population. And it could be anything. So let's just make it simple. We'll do what we did in class. So for the young group, we're going to make the standard population the sum of the two individual populations, right? Stratum-specific populations for each community. So what we'll do is we'll take the 6,000, because there's 6,000 young individuals in community X, and we'll add it to the 8,000 because there's 8,000 young individuals in community Y. So we'll just get here 6,000 plus 8,000. 6,000 plus 8,000 equals 14,000, right? So standard population young equals that, all right? So let's make the standard population old. And then here we'll do the same thing. We'll add the 7,000 old individuals from community X to the 5,000 old individuals from community Y. So 7,000 plus 5,000 is 12,000, right? So that's 7,000 plus 5,000 equals 12,000. All right. So there we have 14,000 young and 12,000 old individuals. Okay. So now the last thing we need to do is to create the total standard population. So the total standard population is, well, here we add 14,000 youngsters plus 12,000 old folks equals what? 26. Sorry, equals 26,000, right? 26,000. All right. So we have 26,000 as our total standard population. So now what we're going to do is we're going to apply these death rates to that standard population. So let's just do something here quick. I love using all these little functions. I'm just going to copy and paste this here, and we're going to make some changes here. Right. Okay, so let's go ahead and change these. Let's change these to the standard population. And same with this. We don't need these deaths right now because those deaths, we don't need them. We're going to do this. So I'm going to rearrange this table. Watch the magic. Watch the magic here. Cut. Let's see if I can do this. Yes. Death rate here. Cut. Okay, so what I did was I just rearranged this table so we have the number of people in each of the two communities, right? Number of people in each of the two communities. Just make this, clean this up a little. So it makes it a little neat. I'm like a neat freak, right? Although you wouldn't be able to tell if you came in my office and saw how messy it was. Okay, so here we are. Everything all set up. Now let's just bring in that standard population. So we have 14,000 youngsters, youngins. Let's call them youngins. 14,000 youngins. We've got 12,000 old folks like me. And then we had a total of 26,000 people, right? Okay, we can do the same here. 14,000, 12,000, and we have 26,000. All right, so okay, so now we're going to calculate. What we need to know is the number of deaths because eventually we have to calculate the we don't really need this one at all, of course, because those were specific to that old sample. All right, so we're going to go ahead and make these calculations. So if we had a death rate of 0.0115 in our former community X, now we're going to apply it to this. We're going to apply it to this new to this standard population. So we're going to take 14,000 and multiply it by 0.0115. So we get, here we go. Let's go. So community X young. Just make sure it's yes. So let's call this X young. Oh, dang it. Ooh, look, I changed the color. So the X young, right? So we have 14,000 times 0.0115, and that, my friends, equals what? 14,000 times 0.0115 gives us 161. So we're going to get 161 deaths in this group. Okay, so let's go ahead and start fill in that table. So we have 161 deaths. 161 deaths. So we're going to do the same here, right? So we're going to take 12,000 and multiply it by 0.016 gives 192 deaths. 192. So see, we're applying these death rates to the standard population. So if this were the population in community X and we had these death rates, this is how many deaths we'd get. So let's do it here for community Y. So now at this point we don't really need to, I don't need to show you the calculation because I think at some point in your career you learn how to multiply, I hope. So we're now for community Y, for youngins, we're going 14,000 times 0.0125. 175 deaths. 175. So you can already see there were more deaths in that community, right? And then finally, yes, Alfin, we got 12,000. 12,000, because now we're doing the old folks in community Y. 12,000 times 0.012, and we get 144. 144. 144. Now we're just going to summate these together. So we're going to add together these values here. So 161 plus 192. 161 plus 192 equals 353. There were 353 deaths. And then, so this doesn't look that hard now that we're doing it this way. So 175 plus 144, 175 plus 144 was 319 deaths, or 319 deaths. 319. Alright, so we're in pretty good shape now. Last thing we have to do is just calculate the death rate. So we're going to make this comparison here, because this is what we had as our original death rates, right? We had 123 deaths per 10,000 in community Y, and 141 deaths per 10,000 in community X. So let's see what they are now. Let's see what they are now. Yes. Let us see. Let us see. So let's clear this here, and we go 353, because we want to know the death rate for community X. We're dividing 353 by 26,000. So 353 divided by 26,000. And then we're going to multiply it by 10,000 since our rate base is 10,000. So times 10,000, and we get 135. So we go, oh, actually, let's yes, we're going to. I'm hesitating because I'll show you 135, but that's not what I want to write over there. So actually here, I'm going to write 0.0. Okay, so divided it back by 10,000 again. So I want to just do the death rate without giving you the base rate here, but we'll write the base rate right here. So we have the death rate, or mortality rate. Let's call it the age adjusted mortality rate for community X. That's where all the hipsters live. Or was it community Y? One of those is the one where all the hipsters live. Community X is, and then we multiply this 0.0135 by 10,000. We get 135 per 10,000 population. All right. Now let's do the same for community Y. Community Y is a different type of population. Less hipsters, different kind of people there. I don't know. You can tell me what kind of people live in community Y. Why? I don't know. But that's why they live there. That's where they live. All right. So let's go. Here we're going to calculate the death rate. So we're doing 319 divided by 26,000. So let's do that. 319 divided by 26,000. We have 0.0. Let's just put this 0.012, 0.012. Let's round this up to 3. So 0.0123. 0.0123. All right. Now we'll multiply it by 100,000, right? Because we want to report it per 10,000. I keep on saying 100,000. I must want $100,000, right? I got 100,000 on my mind. Or 100,000 scones. I'm a big scone fan. I like scones. Yes. Okay, that's it. So if we multiply 0.0123 times 10,000, right, times 10,000, we get 122.69. Let's go to 123. So age adjusted mortality rate for community Y, where the hipsters don't live, is, what did I say, it was 123 per 10,000 population. So that, my friends, is how you do this assignment, this work, okay? Got it? So what did we learn here? Let's see, I don't know if there was any difference, I just made up these numbers. So originally, the death rate in community X was 184 per 10,000, and it was 160 per 10,000 in community Y. So it was higher in community X, right, than community Y. Any difference here? Let's see. Well, in community X, it's 135, so it's still higher in community X than it is in community Y. Although the difference, I think it's a little bit less, right? There's 12 deaths difference here, and here, oh, it's 24 deaths difference. So the difference shrunk a little bit when we did the age adjustment. So the age adjustment helped in that way. So we got a better estimate. That's it, friends. I'll see you in class, and tomorrow we're going to do a lot of exercises, okay? I mean, mathematical exercises, not physical exercises. Bye.
This is so nuts. I mean, listen to what you're saying. It's paranoid delusion. It's really sad. It's pathetic.